Hi everyone, I'm Dr. Saranya and here we are just going to discuss a topic in computer networks that is about digital to digital conversation. So how the digital to digital conversion is happening. So we are just moving into the presentation in detail. Let's get started. So what is line coding? Converting a string of ones and zeros into a sequence of signals that denote the ones and zeros will be called as line coding. So when you are transmitting a data, it will be finally converted into a binary format. That is what about is happening in the case of line coding. So for example, a high voltage level could represent a 1 and a low voltage level could represent a 0. This is what in the data transmission also it happens. So if you see the line in line coding and decoding process, there will be an encoder and a decoder. Encoder will be present at the sender side, whereas the decoder will be present in the receiver side. So a receiver and a sender is present, encoder and decoders are present. In between the network, a link is being connected and a digital signal is transmitted. So this digital signal that is getting transmitted will be in the form of digital data, that is in the form of zeros and ones. So this can be done by using line coding method. So the next is about mapping data symbols onto a single, that is how the signal levels happens. A data symbol or an element can consist of a number of data bits, that is ones and zeros, or two ones or two zeros, whatever it might be. The data model can be coded into a single signal and it will have multiple signal elements into it. So there is no condition that only one element must be there. There might be a series of elements. So when the relationship between the data rate and the signal rate, if you see, the data rate defines the number of bits sent per second in BPS format, whereas the signal rate is the number of signals sent in the form of second and it is measured in bands. So here BPS bit rate, whereas here it is in the form of band. The main goal is to increase the data rate while reducing the band rate. So this is how the signal element versus the data elements are being displayed. If you have one data element for one signal, it will be in this order. If you have two signals, it will be converted into this format. That is, ones and zeros will be represented with the lower and the top level of the graph. Whereas if you have two data elements, it will be holding up with the two data elements like this. And if you have four data elements, the data transmission will be represented with this format. So this is how the signal representations can be made from based on the input, the data elements that you are giving. So the data rate and the bond rate, if you take bond rate or a signal rate, can be expressed as S is equal to C into N into 1 by R bonds, where N is nothing but the data rate, C is the case factor, either it might be a best case, worst case, or an average case. R is the relationship between the data element and the signal element. So this is how the bond rate is being calculated based on the product of these three values. And if you take this example, you can able to understand a signal is carrying the data in which one data element is encoded as a one signal element R is equal to. If the bit rate is 100 kbps, what is the average value of the bond rate if C is between 0 and 1? So C is between 0 and 1. So we assume the average value of C is 1 by 2. So the bond rate will be calculated as C is into N into 1 by R, which is equal to C is 1 by 2, whereas this is 100 kbps, so it is being mentioned as 10,000, and into we have only R is equal to 1, so 1 by 1, which is equal to 1000. So 50 kbps of data can be transmitted with this set of given scenario. So what is line encoding actually? So the line encoding will be happening with the help of a DC components. So where the voltage level remains constant for a longer period of time, and this is an increase in low frequency of the signals. So most of the channels will be bypassing their data during the high frequency time and may not be supporting during the low frequency conditions. Next component is about self-synchronization. The clock at the sender and the receiver must have the same bit rate. So bit interval rate means if one is moving and the next within 2 or 3 seconds the next one has to move. So both the side, the sender side and the receiver side, the bit rate with a bit interval is normal and it is common. There will not be any break in data transmission. If the bit interval is changing, there will be a change in data that is being passed from the sender to the receiver. So this is the effect of lack of synchronization. So both the things has to be in the same time interval. So here the sender is sending with the time interval of one set, but the receiver is receiving it in the different format. Here the echo is being received. So this is effect of lack of synchronization. So sender and the receiver is not synchronized properly here. So they are facing the problem in receiving the data. So bipolar is nothing but it is another one alternative method for non-return to zero. That is NRZ is nothing but non-return to zero. So has no DC components or a baseline monitoring. This has no self-synchronization method. So no error deduction is also done in this condition. So this is another one type of data transmission, that is bipolar. So single polar and bipolar are there for data communication. So these things will be making up the data to get transmitted from the sender to the receiver without any time gap, and they can able to manage your data in a proper synchronized manner. So that is why they use the data transmission in the form of binary values. Those binary process is being done with the help of line encoding methods. So thank you for watching this video, and we'll have some clear idea about what is line encoding. Thank you.